Hello everyone, welcome back to my YouTube channel. So today I'm here to discuss about the topic selection sort with time efficiency. So let's get started with the topic Introduction to selection sort with time efficiency. Selection sort is a simple sorting algorithm that repeatedly selects the minimum element from an unsorted portion and swaps it with the first unsorted element. It is one of the most intuitive sorting algorithm but not the most effective in terms of time complexity. Despite its inefficiency for large data sets, selection sort can be useful for small data sets or as a building block for more complex algorithms. Before looking into the selection sort algorithm, let us learn what is algorithm. Algorithm is a sequence of unambiguous instructions for solving a problem, that is, for obtaining a required output for any legitimate input in a finite amount of time. So the notation of the algorithm is problem to algorithm, algorithm to the computer. Computer has its input and gives out the output. So here is an algorithm for selection sort. Selection sort consists of an array 0 to n minus 1. Sorts a given array by the selection sort. Input an array A 0 to n minus 1 of orderable elements. The output will be array of A 0 to n minus 1 sorted in non-decreasing order. For I equal to 0 to n minus 2 do, the minimum value is I. For j equal to I plus 1 to n minus 1 do, if A of j is less than A of minimum, then minimum is j. Swap A of I and A of minimum. How selection sort works? The selection sort algorithm divides the input array into two parts, the sorted subarray on the left and unsorted subarray on the right. In each iteration, the algorithm finds the smallest element in the unsorted subarray and swaps it with the leftmost sorted element. This process continues until the entire array is sorted. Analysis of selection sort. The input size is n, the total number of elements in the array. The basic operation is comparison. If A of j is less than A of minimum, the basic operation depends only on the array size n. So here is the time complexity of the selection sort algorithm, that is theta of n square. Thus selection sort is an theta n square algorithm on all inputs, but the number of key swaps is only theta of n, or more precisely n minus 1, one of each repetitions of I loop. This property distinguishes selection sort from many other sorting algorithms. Time complexity of selection sort. The time complexity of selection sort is theta n square, where n is the number of elements in the array. Selection sort has a worst case, average case, and best case time complexity theta n square. This is because the algorithm always has to scan the entire unsorted portion to find the minimum element. Space complexity of selection sort. Selection sort has a space complexity of theta of 1 because it only requires a constant amount of extra space for swapping of elements. Unlike other sorting algorithms like merge sort or quick sort, selection sort does not require additional space proportional to the input size. Advantages of selection sort. Selection sort is a simple to implement and understand, making it a good introductory algorithm for beginners. It is an in-place sorting algorithm, meaning it sorts the elements within the input array itself without needing the additional memory. Selection sort is stable, meaning the relative order of equal elements is preserved during the sorting. Disadvantages of selection sort. The main disadvantages of selection sort is its time complexity, that is theta of n power 2, which makes the inefficient for large data sets. Selection sort performs poorly on already sorted and nearly sorted array as it still has to scan the entire unsorted portions in the iteration. It is not suitable for real-time applications or situations where the time efficiency is crucial. When to use a selection sort? Selection sort can be useful for small data sets where simplicity and ease of the implementation are more important than the time efficiency. It can be a suitable choice for when the output size is very small or the data set is nearly sorted. Selection sort may also be used as a teaching tool to introduce the concepts of sorting algorithms before moving on the more efficient ones. Comparison with other sorting algorithms. Selection sort is outperformed by more effective sorting algorithms like quicksort, merge sort, and heap sort in terms of time complexity. Quicksort and merge sort have an average case time complexity of zeta n log n, making them more suitable for large data sets. In practice, selection sort is rarely used in performance critical applications due to its inefficiency. Practical considerations for selection sort. When considering using selection sort, it is essential to weigh the simplicity of implementing against the potential inefficiency for larger data sets. Selection sort may be a good choice for educational purpose or for sorting very small data sets where performance is not a primary concern. For most real world applications, it is recommended to use more efficient sorting algorithm like quicksort or merge sort. Conclusion. Selection sort is a simple and intuitive sorting algorithm that is easy to understand and implement. However, its time complexity is theta n square, making it inefficient for larger data sets and compared to the other sorting algorithms. When choosing a sorting algorithm, it is essential to consider the trade-offs between simplicity, time efficiency, and space complexity. So thank you for watching my video. Like and share the video.